This compact device performs electrochemical impedance spectroscopy. The system maintains stable temperature of electronic components and fluidic samples. The measurement eliminates the influence of temperature, chemical contaminations, electromagnetic emissions, and mechanical distortions. This enables accurate differential measurements, where properties of two fluidic samples are compared with each other. The electrochemical difference between fluids can indicate some experimental factor impacting one of water samples. Such experimental factors can be, for example, weak emissions or information imprinting phenomena. The differential spectrometer can reliably detect such factors after the exposition or even in real time during the measurements. Connect the spectrometer to USB active hub. Use short USB cable. Connect the water containers and electrodes with the spectrometer. First, fully insert the connector and then screw the metal fixator. Insert the water containers into the thermostat. Select in the box that COM port that appeared after connecting the spectrometer. The operating system of the spectrometer sends the status information to the client program. In the first selector, you can see the device ID and temperatures of the thermostats. Here, you can start and stop measurements. For the test measurement, we consider the case when fluidic samples are exposed by experimental factors before measurements. The idea of these measurements is based on observation that fluids electrochemically degrade over the time. The reason is a self-ionization of water molecules and absorption of CO2 from atmosphere. Weak emissions can influence the degradation rate. Two unexposed samples degrade similarly to each other. The degradation rate of exposed and unexposed fluids is different. Comparing the degradation rate allows detecting the exposition by weak emissions and information imprinting phenomena. Prepare 4 samples. Expose one sample by experimental factors for several hours. Here, different combinations of imprinting devices are possible. Other 3 samples should be stored closely to each other and away from the first sample. After the exposure is finished, measure first 1 exposed and 1 unexposed samples. Now, insert into the thermostat 2 unexposed samples. Perform the same steps as with the first pair of fluids. After finishing all measurements, you will see 4 curves that indicate each of containers. Differential channel demonstrates different inclination of experimental and control curves. Different dynamics of both pairs of samples is visible on the bar diagram. The intensity of impact can be estimated based on difference between experimental and control measurements. Large difference means large impact, no differences mean no impact. This is the general rule for impact assessment. Impedance spectrometer allows detecting the impact and estimating its intensity. For detection of biological influence, other devices have been developed, for instance, based on the fermentation test with yeast.